Is anybody willing to share?
Oh, I put mine in the chat already.
Okay, okay, okay. Let me check that out. Oh, I can say that. Okay, because I was logged out. Please, can you resend it?
Absolutely.
Please. If you have pasted your own earlier, kindly resend. I got logged out now and I'm just coming in again. Okay. Okay, Jeffrey, I'll be an applied mathematician and a jazz pianist or classical violinist. Wow. They have both a varying degree of non-linearity and chaos. Wow. I say that. Would you love to give more explanation on this and why? You
Oh,
can unmute yourself and share.
absolutely. Um, I mean, applied mathematicians a lot of times, when applying mathematics to real world situations, you rarely have uh, idealistic situations, rarely, if that's ever a case. So there's a lot of non-linearity and probabilistic results that you have to derive, um, to in terms of solving your use cases. Um, I think that's also very similar to what jazz pianists and classical violinists have to deal with. More so, jazz pianists. There's a level of chaos. I mean, but what we also learn from chaos theory is there's a level of order that comes with non-linearity, although it seems abstruse. Um, but however, it's still non-linear. As much order as you can try to put to that is still non-linear. So these these two areas metaphorically have great connections for sure.
Okay, that's great. Thank you. Is there anybody that wants to also share anything, either via chat or we should just go ahead? Okay, for me, let me share mine. For me, love to be a computational physicist and a counselor. A counselor. I believe there's a connection between the two. And the connection I believe exists has to do with the fact that for every challenges an individual is going through, we can actually have a computational representation of that situation whereby the input that comes in to a large extent determines the output that you get. And so, as a counselor, having access to someone who probably have had some unpleasant experiences in the past, there might be tendency for the person to actually maybe be weird in behavior or maybe be violent based on the experiences in the past. So I consider those ones as inputs, the same way we have input in computational research. And then at the output will be if as a counselor, you can be able to work on those inputs by introducing some variable that will disabuse the mind of the person that the fact that you were abused in the past does not mean you should also be a bully or live a weird life. I believe at that point in time, the change can take place and the person can actually turn out to be a better person. So I see the connection from that perspective. And we can link this in order not to waste the time too much this morning. We can actually link this to the whole idea of quantum mechanics superposition, whereby we believe that the particle can exist both as what? They can exist both as a wave and what? As a particle, okay? And then we'll link all this to the concept of quantum computing where we talk about qubits and the rest of them. So we can actually look at the variation of all this vis-a-vis what we are doing today. Today we are looking at Python for quantum computing. And I believe our guest lecturer today will be delving into the details of what we can learn from that. And then we can also be able to understand some of the concepts that are deeply and intrinsically loaded as far as quantum computing and the quantum science is concerned. So, having said that and having discussed that very briefly, I want to welcome every one of us one more time to today's webinar. My name is Professor Akinlola Yinka, and then the convener of this webinar. I don't know, we don't have so many persons on ground yet, but we cannot afford to waste the time. Okay, so I have somebody who would like to be a physicist and a preacher. Danladi, that is a great one. Okay, so we have to move ahead. I believe others will be joining us in the course of the meeting. Our presenter today is speaking to us from the United States of America, and he has denied himself of sleep to have been able to meet up with us here. So we need to start right away without wasting more time. Today, we are continuing the part 2 of series on Python for quantum computing. Last month, for those of us that were around, we had a great experience listening and learning hands-on with Jeffrey Ojuderi, okay? And then today, he's here again loaded to actually build on the foundation that was laid last month, precisely about 4 weeks ago. And so I want us to be attentive and pay attention. However, before going into lecture proper, I would love to go through the citation of a presenter very briefly. And please, I would like you to pay attention. So Jeffrey, you can maybe on your video for real life visual, okay? So then I will project this time I will project your citation so we can read even as I go through. Our speaker today, Jeffrey Volker Ojoederi, is actually a distinguished full stack scientist. And I would love to say that Jeffrey was my former student. And I'm proud to be associated with him. I am proud to have been, in fact, I would say I'm proud and privileged to have been his lecturer. I know exactly what I'm saying. When you have a student that is extremely promising, humble, and forthcoming, as a teacher, as a lecturer, you are proud and you consider yourself as a privileged teacher or lecturer to be able to impart and add a little value to such a student. And so I am privileged and I'm proud to be his lecturer at his undergraduate days. Presently, he's with Photon 3 with a unique blend of physics, mathematics, and advanced programming expertise. He's a graduate of Benson Idahosa University here in Nigeria, where he had a bachelor in physics and mathematics, actually a double honor. And he graduated with an impressive, exceptional CGPA of 4.98 out of 5.0. I believe our guest lecturer deserves an applause. Jeffrey also has dual master degree from the Hort International Business School in business and also in finance. With over 6 years experience implementing complex computational solutions, Jeffrey Volker has led significant projects across various Fortune 500 companies, including Vanguard Group and Gap Incorporated. The expertise of our guest lecturer today spans across quantum computing, machine learning, deep learning frameworks, making him particularly well suited to bridge the gap between the theoretical physics and practical programming applications. At the Vanguard Group, Jeffrey pioneered the development of advanced AI systems, including large language model-based solutions while also conducting regular Python workshop for employee upskillings. His current work at Photon 3 involves developing sophisticated algorithms and also scaling complex computational model for effective use and deployment. Today, Jeffrey will continue sharing insights and leveraging on Python for quantum physics applications, drawing from his strong foundation in both theoretical physics, mathematics, and the practical program implementation. I believe there is no other better person to be speaking to us on the topic of Python for quantum computing other than Jeffrey Voke Ojuederi. Please join me to welcome our presenter, our guest lecturer this morning, Mr. Voke Jeffrey, as he takes over the show from here. Jeffrey, you're welcome.
Oh, thank you so much. Blessed morning, everyone. I appreciate the opportunity to be here for sure. Um, Thank you, sir, for being an exceptional professor, a guardian, mentor, all these years. I'm very
Amen.
grateful for the opportunity, for sure. Um, I would quickly share my screen. Uh, I guess everyone can see my screen now.
Yes, we can. Yeah.
Um, to do this. Okay, good. Um, if I keep turning my head, just I'm also looking at my reference screen. Don't worry, I haven't left us behind. Last week we essentially went through setting up your Python environment. Um, I do see some faces. Well, I do see some names that I don't really recognize from last time, but assuming we've been able to reference the materials that were put on the
Cool.
um, group chat, and so we wouldn't spend a lot of time, going over, or at least we'll just try to avoid the redundancy.
Yeah.
We set up our environment. We went through some Python basics. Went through. Let me see. We didn't get to go through some foundational concepts of quantum physics, but we essentially just went through some Python basics. Um, went through data types, went through what variables look like. We didn't go through loops and conditionals or functions or importing libraries. We'll more so jump to, so today, really, we'll just kind of do a quick run through of what went last week, then jump into importing libraries, understanding what libraries are, how to import them. Given that you already have the materials available to you, I would imagine that it will make sense to more so do like maybe do some examples of pure Python, like syntaxes and use cases, and then maybe treat 2 to 4 quantum physics use cases where we're applying Python, if that makes sense. Now, you might not understand all the codes, but remember you have the materials available to you that you can always reference. If you are not aware, it's on the group chat. Professor can always have them available to you as well, if need be, if you can, see them. So we'll try to explain the codes as much as possible. We'll try to have you run them on your system just so it whets your appetite in understanding how you could use Python for quantum physics. If you're not using quantum physics as much, or you're not necessarily aligned to this experience, you should know that, as we mentioned last time that we met, Python has a plethora of libraries that can be used that chemists could leverage, applied physicists, applied mathematicians, biologists, statisticians, whether you're in machine learning or whatever the case may be. There's so many libraries that you could use with Python, and they are largely free. You don't have to pay for them. So that's a good incentive, I should say. So let's jump right into it. As we did last week, remember we learn best by it being hands-on. So I would give like a second for you to like fire up your laptop, get to Google Colab. This was, I don't know if you can see my Colab screen. If you can't, let me just share the
Yes,
whole.
we can. Yes,
Okay,
we can.
fantastic. So um, once you have your Colab up and running, just give me like a thumbs up so we'll jump right into it. You could just give like a thumbs up in the chat so I know that, or you could just say you're good to go once you have your collab screen up and running. I don't see thumbs up from anyone. Is your collab up and running? I just want to make sure we're all following. So I'll probably give like a minute before jumping in.
Okay, for those who might be joining for the first time, I've just shared the link on the chat. Okay, we have a thumb up from Omiakere Dolu. You're welcome. So for those who might be joining for the first time, there's a link I've just shared. I can take you straight to Google Colab where you can run Python code on the Google machine. Okay.
Okay, so we'll give another 1 second just to click on that and get ready to go. If you have any questions on how to fire up your collab, kindly indicate, but it's relatively straightforward. Okay, so we have another 30 seconds, and at exactly 10:30 we'll start. 15 seconds. We'd love to see more thumbs up here that we're ready to go. Okay, thank you, sir. Okay, so now let's jump right into it. The last time we met, we looked into different concepts within Python. I'm going to give like a 30,000 feet view, high level of what we did. Um, we ran our first code to feel good about ourselves. Let me know if you can see my, because
Can you
I like,
please zoom your screen a little bit?
I thought as much. I like my
Um,
my
Great.
code's a bit smaller, but this should be
Yes,
good, right?
it's good for me. I think it should be good for everyone.
Okay, sweet.
Please let's respond to some of these. Let's make it interactive. When the lecturer speaks, please let's respond through chats, through enemy, so that we can be sure we're together. Thank you.
Yes, sir. I agree with that. So we run our first code, the hello world, so we feel good about ourselves. That was successful, had a lot of traction with people actually having a good time going through it. We looked at variables, we're understanding that variables are essentially buckets that you put values into, and you could call variables anything. We looked at different ways to not name variables. So essentially, don't use capital letters, don't start with numbers, don't give, if you have a variable that's like two names, say, let me just quickly, again, this is going to be like quick overview. So if I had a variable that says, maybe my variable is sum of odd numbers, this is how you want to be naming it, right? So let's say 5050. So the sum of what the first, what, 100 numbers, 100 natural numbers. So instead, this is how you want to be naming it, not naming it like this. Yeah, we looked at different ways you shouldn't name. So this is an example. Keep your variables simple. Let it make sense. If you're using multiple words, you want to use like underscore to connect those words. Your variable shouldn't be overly verbose. I know that we kind of dealt with those. Um, Taking this script here where we had printing a hello world, we decided to actually apply the concept of variable naming. Now, using J as hello world is not exactly the most intuitive um, variable naming, but it served the purpose here. We looked at the statement, how to actually store an overall string within a variable name as well. Now we looked at data types, and we looked at how to check for a data type using the type method. These are the I think we already done numeric data type, of course, with these strings. This is exactly what a string is. We mentioned that once you have a quotation, double or single quotation, it's a string. Whether it's a number that is within those quotation, Python recognizes it as a string. Um, we looked at numeric, which is what we'll call an integer or a float. We looked at complex numbers. Remember to um, for a value to be recognized as a complex number in Python, it has to have value j. So it will be 2j, 3j, 4j. I know in mathematics, the convention is I. In Python, the convention is j. So we looked at that as well. Then we went to lists. One of the things that we talked about was lists are an unordered arrangement of multiple data types, meaning when a list is created within Python, it doesn't have to be in order. It doesn't have to have just one single data type. That means it doesn't have to be just an integer or just a string or just a complex number, whatever the case might be. It could be multiple data types with unordered arrangement. So it could be a bucket of red, blue, green, um, white balls all together. That's what a list is, and it can have duplicates. We established that. So we're going to go right from this place to, let me see, I prepared some scripts that could potentially help us out. While I pull that up, do we have any questions so far? Please, let's make this as interactive as possible. If you have any questions, we would definitely love to hear from you. Questions, contributions, you might have tried something out on your own and you feel like, okay, this actually worked well. I enjoyed doing this, or this didn't work as well. We could answer that now before we keep going. Going once, twice. Okay, let's keep it moving. So now we're going to look into what we call sets. If you need help, again, I think we mentioned the last time, you need to make your code file as uniform and as clean as possible. So instead of having excessive comments, you could use the text function to sort of have like sectional headings, right? Um, so here we're going to be talking about sets. What are sets? Sets are unordered collections of unique items. So right away you see that there's there's a very distinctive difference between what sets are and what list is. Lists allows duplicates, sets do not. Immediately, that would be the major difference that you see between both of them. List allows duplicates, sets do not. So what's the syntax? So let's call this my set. For the set function, you use curly brackets or curly parentheses. Now, do me a favor, create a set of values for specific even numbers. You can start from 2, you can start from 10, but let it be 10 even numbers. Someone should let me know once they're done. And then confirm that it's a set by using the type function or the type method. It's quick, it's very straightforward. So someone should kindly let me know when they're done. Anyone done yet?
Hello.
Yes, sir.
Please, sorry to draw you back. I'm trying to. I thought Prof said he um posted a link to Google Colab on the platform. I can't see it.
Oh,
Okay.
okay.
It was pasted on the chat. Okay, I'll paste it on also our chat right away so that you can have access to it. I have it on the WhatsApp chat now. I'm also pasting it again on the Zoom chat. So whichever one is convenient for you, you can make use of the link, sir. Would that be fine, sir?
Yes, yes. Thank you.
Okay. You're welcome, sir.
Okay. Okay, I see you've created 10 even numbers. Okay, did you confirm that it's a set type using the type method? Ayinde, please, did you confirm that it's fantastic? I don't want to butcher anyone's name, but great, great. That's great work. So that's one way to create a set. Let me show you another way to create a set. So create another set and call it empty set, right? And while doing this, use the set method for the same sets of numbers, even sets of numbers that you just did. You will see that it will give you exactly the same thing. Good. You see that it gives you exactly the same thing. Now, let's take probably one or two basic set operations, right? And for this, our unique purpose would just be for integers. So within set operations, you have addition, subtraction, you could remove, or well, that's technically that's subtraction. You could discard, and then you could uh, perform like unions and intersections. I'll pick just 3 of these to do. The book that we send has a lot of this information in there, so I won't waste a lot of time here. How would you add values to a set? I hope we're following. So let's say I have my empty set, but I want to add the value, let's say 22. I use the add method and it's done. If I print out my empty set, you see 22 is right there. Let's run it another time. Let's add the value 100, which is also an even number. That's it. That's how you add values to your set, to your empty set variable. Has anyone tried it? Adding values to your set, your empty set variable using the add method. Has anyone tried it yet? Sweet. Ezekiel, you're on fire. I love it. Okay, so let's try to discard. So in this case as well, you have to provide what element you want to discard. So let's say I want to discard 2. When you run your empty set, 2 is gone. Let's say I want to discard 100 too. It's a bit too large for the sets of numbers that we have. It's not following any pattern. You'll notice that it's gone. Great work, great work. Emmanuel, I just saw your response. Great work there. So again, to add elements to your set, your empty set variable that represents a set of numbers, you use the add method. To discard, you use the discard method. Really that simple. So the syntax is, let me give you a good way to think about it, because this often helps me. The syntax is this. Set variable, so which is your variable name that represent your sets of numbers, dot method
Okay.
value. I know it seems abstract, but what this is saying is the name of my set of numbers, that's the name of my variable that represent my set of numbers, dot. The dot means I'm calling that method. Now, this method here could be add, it could be discard, as we just did. Add or discard the value I want to either add or discard. That's the syntax. I'm just going to type it out here for anyone that might want to reference it. So that this is the syntax. So whether you're trying to add to your sets of numbers or discard from, this is the syntax that you could use as a general case. Now, let's say I want to remove elements without essentially specifying which element I want to remove. There's a method called pop. Remove elements without specifying the value. There's a method called pop. Pop is essentially taken from the first sets of values. So let me do that. I know it can get very abstract, so I'm treading very carefully here. So let's say I'll call my new variable removed element to show the element that's been removed. And then I'll say empty set dot pop. Before I even run this, which element will be removed? If you had to guess, based on what I said, first in, first out. Someone can quickly respond, see, getting something wrong doesn't mean you're terrible. It's part of the process. Who would like to take a guess? We have a set of numbers 4, 6, 8, 10, 12, 14, and 22. Which element will be popped based on the first in, first out principle? Just think about it. First in, first out. Anyone? Okay. Okay, I think someone might have responded. 4. Yes, sir. You are exactly correct, Ezekiel. 4 is out. So apply the same methodology to your sets of numbers. Why is this even important to have? There are times where you might be running a script over a large number of sets, and you can essentially, especially if you're looping it, like if you want it to repeat, you can manually be putting the numbers that you want to take out, but you could actually use the pop method and strategically remove numbers from the beginning of the set, if that makes sense. So let me know if you are able to do the same thing. I'm sure you can do that quite simply. That shouldn't be a problem. Now, clearing all elements from your set. The syntax is exactly the same. Variable, variable name dot method, but in this case, you're not calling any value specifically. So in my case, empty set dot clear. You know what? I might want to reference that later, so I'll just say this. And if you check new set, it's empty. There's nothing there. So yes, yeah, Emmanuel just responded yes. The pop method removes the first term first. And as you keep running it, it's going to keep removing the first term until you have no other, until it's an empty set, essentially. Now, we just showed that you could clear all your elements from your set just like this at the snap of the finger. How? By calling the clear method on that set. Now, what I did was I stored that in another variable to ensure that my empty set is still intact, but my new set would have the cleared empty set of, not to sound very tautologous here, but essentially this empty set that has this set of numbers, after clearing it, all of it will be stored in new set. That means new set has no value essentially. So please run that, and then let's see if we can do a quick union function within this set method before we jump into the next phase. If you're able to clear, give me a thumbs up. I know you could also unmute your microphone. It would be nice to also hear you speak as well, kind of like what Isaiah did. Has anyone cleared yet? Very easy. Get your set variable name dot clear. So call that method. When you have dot a specific key name, it's often a method. That's what's called in Python. So Mr. Ezekiel, Mr. Emmanuel, oh, nice. Thank you. Done. Good, 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 good. Anyone else? I'll probably give like another 5 seconds before we do some more interesting um, set calculations and quickly jump out of here. Done. Nice. Okay. Now, I would like to think everyone here loves mathematics. So we do remember what union is, right? Two
Hi.
independent. Mr. Ezekiel, sorry, you said?
Yeah, I said this operation does it work for list?
So list uses a completely different set of operation, but for list you could use pop. Pop works in list too. Yeah, so list has its own um, has different operations essentially. For example, you can't necessarily union list the way you would in set, right? So it's unique. But for more in-depth
Okay.
information, you can reference those books that were passed along for sure. Great question. If you have two independent sets, union of them, A union B would be A plus B. Remember that from from elementary mathematics essentially. So let's say we have two sets. Now let's do this. Let's create two sets. Let's say call one set A. And remember, I showed you that two different ways to create like your sets, right? And let's call this list of numbers, all natural numbers 1 to 10. And then set B, let's call this list of even numbers uh, to 10. How many of us have done this quickly? Let's do that real quick. List of numbers 1 to 10, list of even numbers um, between 1 and 10. Now I want to find the union of these two sets. I'm guessing we've done that. I trust us, and I know we're on track. So the union set would be set A, calling the method union, set B, return union set. Does this make sense? By definition, remember that for two independent sets, A union B is equal to A plus B. And this generally is a subset of this one. So that's why we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make it more interesting. Let's do just odd numbers here. 1, 3, 5, 7, 9. And we run this. If you notice, there's no difference. Because based on our definition, it's combining these two independent sets together. Let's try another example. Set X. Let's call this, let's say 1 to 20. I don't know, let's say 12. 12 will be, 20 is a bit. And then let's set y be the square value of the first 5 digits. So we have 1, 4, 9, 16, 25. Now let's find the union set of these two sets. So union set is equal to first set dot union set y. Okay, I want to return this union set. Anyone with me? Because you can see the result now has the first values up here, 1 to 12. Then we also have the common values 1, 4, 9 between both, which will be the intersecting values. And then we'll have 16 and 25, which are additional values that is added to the last part. Yes, sir. Yes, I'm glad you're following for sure. Anyone else following? Now, what is the general case of what this syntax is? Yeah, thank you so much, Mr. Ezekiel. The syntax here is simply set A dot union set B. That's it. That's the syntax. Simple enough. Now, let's do intersection. Please, if you have any questions, kindly let me know. I don't want to spend too much time here because we have to quickly jump into other things. I think I've spent a lot of time here. So A intersect B for two independent sets, A, B, would be A times B, right? So let's take this. I will know that by definition, essentially it's talking about, intersection is talking about values that are common to both sets. The syntax, as you would imagine, is exactly the same thing. Intersect set is equal to set X dot intersection set Y. As you can see, it gives us just the intersection. Again, the syntax here, I'm just going to put the syntax at the top. Very easy. Set A dot intersection set B. And there you have it. So do me a favor. Create two sets. One of even numbers from 1 to, the square of even numbers from 1 to 5. And then your second set, odd number, square of odd numbers 1 to 5. And find the intersection. Let me repeat. Create two sets. Your first set should be the square of even numbers 1 to 5. Your second set should be the square of odd numbers 1 to 5, and find the intersection. Let's see who can quickly get this done for us. Let me know you're done, and let me know when you're done, and let me know your results. If you have an error, it doesn't mean you're terrible. It just means that you're actually writing a code because everyone has them. Okay, we'll have like a minute to get this done, and then we jump into dictionaries. After we do dictionaries, then we should be good to start calling libraries. Anyone done? I believe in us. I know we can do it. Mr. Ezekiel, Mr. Emmanuel, I know we can do it. I haven't heard from some people here yet. I would love to have others chime in too. Anyone done? You used the first example. Okay, so let me understand. Did you create two sets, one set being the square of even numbers 1 to 5, even numbers between 1 to 5, and the square of odd numbers 1 to 5? Great, great, great. Okay. Empty set. Beautiful. That's it. That's what I was looking for. Empty set. Because you wouldn't have no commonalities. So let's do it so that everyone can see. Um, List objects. So if you are using this square bracket, you must be using this set function. So Python is seeing that you are creating a list. You know what? You could share your screen so we see what was going on. It could be a good teaching method for teaching avenue for everyone. Essentially, your type is not a set. What you have is a list. That's why Python is giving that error. One way you could check is just call the type function on your variable, as we said. So let's say your variable was set x. Just say type set x. Python will probably tell you that it's a list. That's why you're getting that error. Emmanuel, let's quickly fix that for you. Oh, beautiful. So you're good now,
Okay.
right?
Good.
Fantastic. That's good. Um, let's do the exercise. So we have, let's say I'll call this set V, and I said is essentially the square of even numbers between 1 and 5. So that will be 4 and 16. Yes. So the square of 2 and the square of 4. And then the square of odd numbers, let's call this W, between 1 and 5. So that will be 1, 9, and 25. Right? And I'm trying to find the intersection between both. So this is set V dot based on the syntax. First set dot intersection parenthesis second set. And I do not necessarily have to equate that to anything. So you see, it gives us empty set. It tells us that there's nothing. Now let's go back and see everything that we've done when we're talking about sets. We did lists before and we said lists can have duplicates. Sets cannot have duplicates. because by definition, it's a collection of unique items. So based on the understanding, we created our set. We said there are two primary ways of creating a set: using curly bracket, one, or just calling the set function over a list of values. One thing you'll notice that if you duplicate here and you call this set function, the set will dedupe that list. What it will do, it will remove all duplications and return an ordered unique set of items. Now, after that, we looked at some methods within sets. We looked at adding values to your set. We looked at subtracting values, that's removing or discarding values from your set. We looked at other set operations, specifically around mathematical applications when it comes to union and intersection. Do we have any questions so far? Let's jump into dictionaries if there are no questions. Let's take a deep breath before we jump in. I know it might seem like it's just a lot of information coming down your throat, but it's good for us. All of these foundational concepts are important in being able to independently run your scripts, write your codes, solve your problems, and perform multiple functions. Since there is no question, I would assume we're following, and I'm happy about that. Okay, before oh, okay, Mr. Emmanuel, thank you so much. I'm glad everything is good. What are dictionaries? Before we even define it, think about when you open your dictionary. Those days of having like Oxford, the really big ones, unless you are looking for the word physics. When you open physics, you look for P, letter P, you open it, you see physics, often in bold, right? And then you see the definition of physics. So there are two things happening there. You see physics and then you see the definition of physics. The same concept is happening here. Unlike a set that just has a set of values, dictionaries have key value pairs. That means you have keys and you have values. So think about the word you are searching for as the key and the value that it holds as the definition of that word. Does that make sense? Does that make sense? Please, we could unmute and make this as interactive as possible. I'll repeat what I just said. Think about when you had to open a dictionary to find the meaning of a word. When you get to the word you're looking for, let's say in this case, we're looking for the word physics, and you open to physics in the dictionary. Physics is often in bold letters. And then you have the definition of what that word is. The same concept materially applies here, where the word physics is seen as a key, and the definition of physics is the value. So think about dictionaries as key value pairs. So because the words are the definition, that's the key, the word, that's the key, and the definition, the value, they are paired together. So a dictionary is an unordered collection of items with data stored in key value pairs. Just what I explained. Now, keys must be unique. Keys must be unique and immutable. Means you can change the value, but you can't change the keys. So keys must be unique and immutable. Usually keys are strings, integers, or could be tuples, but for our use case, let's just say strings and integers. Values can be of any type. Any questions? I know I've said a mouthful of things. Oh, Mr. Ezekiel says it makes sense. Thank you. That's very great to hear for sure. Oh, I thought someone was going to say something. Okay. Let me revisit each line I just mentioned. Dictionaries are an unordered collection of items whereby the data is stored in key value pairs, words, and meaning, as we mentioned. The keys, which are words, must be unique and immutable. So once you set your keys, first of all, they must be unique. Two, you can't go change them. You can change the values, but the keys must be unique and immutable. Values can be of any type, right? So in our use case, we're using strings and integers for uh, uh, strings and integers for our key value types, but for values we can use any data type really. Now, to tie this to what you've already learned before, how does this compare to like a list? We know a list doesn't have key value types, but a list has accommodates unordered collection of items, so multiple data types. For sets, each item must be unique. In dictionaries, each key must be unique. I don't know if I'm making sense. Because in my experience, I realized that when learning new concepts, it's important to tie them back to what you've learned before that you've understood. It makes it easier to have the flexibility to leverage the machinations of those new concepts. So I'll tie it again. In list, we found out that list can be an unordered collection of items duplicated if need be. Dictionaries can have unordered collection of items, but the data is stored in key value terms and key value pairs. Just like sets where the items are unique, keys are unique in dictionaries, right? Now, like lists that can have multiple data types, values can be of any type. Any question? Now let's fold our sleeves and get to work. Let's assume we have students and we want to find student informations. Okay, before I even jump in there, how do we create dictionaries? So let's call this dictionary A, and or you know what? Let's keep best practice here. Let's call it example dictionary. Remember I talked about naming variables and making them as intuitive as possible. Now, let me show you the two methods to create a dictionary. Method one, you use the same curly brackets that you used in sets. And then let's call this key your name. And so in this case, my name is Jeffrey. Remember, these are strings, so you have to put your parentheses. And then let's say Occupation. Oh no, let's do nationality. And let's say Nigerian. This is a dictionary. Let's confirm. Type example dictionary. You see what it says? Dict, D-I-C-T, short form for dictionary. Now, name is the key. Jeffrey is the value. Nationality is the key. Nigerian is the value. In other words, you must separate a key and a value with this colon, not semicolon, this colon. If you have multiple keys and multiple values, you must have a comma. Any question? Let me go over that again. To create a dictionary, the first method is to use a curly bracket. And then, as a matter of fact, I will teach only this method because the other method can be a bit tricky. So I'll teach just this method. So the way we did set, you can call DICT and then run your data in there. But I'll teach just this method so we don't get too confused. Once you master this method, you could just keep using it. So you have your curly bracket. The difference between this and set, you didn't have to use any colon to separate your key value pairs because sets do not have key value pairs. In this case, we have two keys, name and nationality. And we have two values, Jeffrey and Nigerian, respectively. So name is a key. That's our first key, with Jeffrey being the first value and the only value for name. Nationality being our second key and Nigerian being its value. Do we have any questions? The best way to master this is roll up your sleeves and actually write it out in your collab. So if anyone is done, let me know. Your name, your nationality. Then we'll start doing some interesting use cases here. And after this, we'll import some libraries and do some quantum physics use cases.
Yeah, done.
Done.
Yeah.
Fantastic. Would you love to share your screen to see so we can all see what you've done? I will stop sharing.
Okay.
Yeah, so you could share yours. Let us know if you had any challenge, if you had like some second thoughts as you're like, oh, wait, this is a bit confusing. And how did you tackle that if you did?
So I'm sharing.
Awesome.
Can you see my screen?
Not yet.
Yes.
Okay.
I don't see a screen yet. Okay, I see it coming up now.
Can you see
It's
it now?
it's completely dark. It's essentially all black. Okay, I see it
Oh,
now. I see it.
okay.
Great. That's exactly it. Did you have any difficulties trying to run it?
Not at all. Not
Okay,
at all.
fantastic. Fantastic. Anyone else? Oh, yes, I see that some of us are getting this done. This is good. Mr. Ayinde, could you please share your screen? Let's just see just one person and Then we'll move on to creating something a bit more fun.
All right. Actually, I'm using my phone for the lesson, but I'm using my laptop to progress. But I don't know if I can do video. Let me see if it will work by showing my screen.
Okay,
Okay, that's fine.
that's fine for sure. I appreciate you all for engaging and actually trying this out.
We are seeing your front camera. You might need to switch to your back camera. Okay.
Okay, let's see what we have here.
Let me try to spotlight him.
Okay. Yes, good work. Good
Okay,
work. Good work.
great.
Good work. So let's do something fun. Based on what we know so far, let's do something fun. Let me know when you can see my screen again.
Yes, it's up.
Awesome. Imagine you had students and you want to have their complete information, but let's say for one student, since it's an interactive class, call out some information about the student that you want to know. If
Um,
no one, if
okay.
no one talks, I will move forward.
Let's say
Age.
Emmanuel.
Okay, someone says, okay, so let's say name. Someone said age. Okay. What else? What else?
Sex. Sex.
Okay. What else?
Religion.
Region.
Religion.
Religion. Okay. What else?
Educational background.
Educational background. So let's call this edu background. Okay, two more. Let's say score.
State of state of origin.
State of origin. That's a good one. So let's say state. Let's just call this state. Okay, good. What is this student's name? I'm following your lead here, so I will need instruction. What's the
Emmanuel.
student's name?
Emmanuel.
Emmanuel. Good. Uh, okay. Age. Anyone going to give me
17.
an 17? Okay. So he's clearly a male.
Yeah.
So let's use M for that. He's a Christian. Educational background. What's his educational background?
Maybe the highest qualification. Let's say
Highest.
first degree. B. PSC.
Oh, fantastic. So let's say what was
Great.
his?
That would have been great instead of score. I will change it to great instead of score.
Okay. Okay. I like that. I like that. So what was the grade, Mr. Yinde?
Okay, let's put 4.660.
4.6. Okay. What's his state of origin?
Osun, Nigeria.
Sorry?
Osun State.
Okay, beautiful. So let's print this student's information out. See, we've created a very useful dictionary. Now, what if we had multiple students? How do we do that? Let me show you what to do. If you have multiple students, this is how you do it. Let's call these students, plural. I'm going to move this down because we're going to be putting a lot of information here. Student 1. You know what? Let me put this in. My suggestion is you should be typing the first dictionary that we just did with this student information. So here, I'm going to copy all of this. I'm going to copy all of this. And then I'm going to create 2 more students. Student 2. Let me know when you're done creating yours. So in this case, I'll call it name Godfred, age, say 20. My keyboard is acting up today. Religion, Christian as well. Anyone done creating their dictionary? Anyone done? Can you speak in your microphone, please? I see this is 4.8. What state should I use? So let's say I use, let's say Ondo State. Yeah, so created 2 students is sufficient. So it's not like an overkill. Let me check the chat. Oh, Emmanuel, I just saw your comment. Don't worry, let's change this to 30 then. And then let's change this to, let's say MSc. Let's print this. Now we have multiple students. Multiple students. Anyone able to do both? Creating 2 students. What is happening here is we have what is called a nested dictionary. So this is one dictionary based on what we did before. And this whole thing is another dictionary within, so a dictionary within a dictionary. Why? So this is a key, and these are its values. This is a key, and these are its values. Does that make sense? Anyone? Any confusion here? Let me explain that again. Student 1 is a key. Name, Emmanuel, age, 30, sex, and all of those parameters are its values. But also remember, name is a key, Emmanuel is the value, age is a key, 30 is the value, so on and so forth. So you see that it's the same construction of key value pairing is consistent both at this what I'll call local level, that's within this name, Emmanuel, and all that parameter, and consistent at the global level, quote unquote, with this student one, student two having been the key with these values, all these parameters being its values. Do we have any question here? Any question? Okay, I guess no question. So if I wanted to change, so let's say we realize that Godfred, we're doing everything by, okay, so let's say for example, Mr. Ayinde is our computer guru. And the information they gave him, he wrote this code. And then they told him, oh, um, we actually don't want to do by first name. We want to do by last name, actually. We want to record by last name. How do you go change this? Remember, we mentioned that the key is immutable. You can't change the keys, but you can change the values. So how is it going to fix that? Now let's try to tackle it. Let's do for this singular use case here. I'm going to copy that here just to rerun it for cleaner operation. Now, to get that Emmanuel to change that Emmanuel value under the key name, I'm going to call my dictionary student and then call name. We want to change that to last name, right? So I'm going to say, let that name, Mr. Emmanuel, I'm sorry, I don't want to mess up your last name. So I'm just going to type it. I've changed the last name. And they're like, oh, no, 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 no. Also, we realized that there was something faulty in the record. He's not 17, he's actually 30 years old. We need to change that as well. Mr. Ayinde says, okay, let's first confirm that my first change reflects. As you can see, that has changed. The name is now this, Emmanuel's last name. Can we quickly go do that in our script, please? And if you do it, kindly share your screen. Let's just have one person do it and share their screen. Anyone? I'll give another 30 seconds. And as a bonus, change the age too. Make an attempt. Given that we've changed the name to another name, assuming the last name, let's change the age too. Anyone? Mr. Ezekiel, I know you've been on fire for us. Mr. Emmanuel, Mr. Isaiah. Some people haven't contributed yet. Mr. Mustafa, Mr. Jonathan, Mr. David. We'd love you to chime in.
I'm sorry, I joined lately, so I'm just following you as you are doing it. I'm sorry.
Okay, sure, no worries.
Yeah.
It's okay. Let me know if you have any questions for sure.
Okay, no problem, sir.
Yes,
Well
sir.
done, sir.
Yes, sir. Anyone done? I'm looking at the chat. I do not see anyone. We have another 30 seconds. Change that name to last name. That's just it. Mr. Yinde got a call from the student affairs department and they say, we don't want to record by first name, want to record by last name. So he had to go into the system, being the computer guru that he is, to change it to a last name. Has anyone been able to do it? Okay, let's see. Mr. Ezekiel is done. Fantastic. Are you seeing the results that is consistent with what we have on the screen? Mr. Ezekiel, are you seeing the same result? And were you able to do the age? Did you try your hands on the age? Okay, so we don't waste too much time. Let me do the age. So you call the key, which in this case is the age, and want to change that to 30. Now, because its data type is numerical, in this case, an integer, we don't have to use parentheses. Let me see, someone just responded. Mr. Great work, great work. So 30, and all I do is run that and confirm. It's changed. So to access the value within a dictionary, the syntax, let me use this here. To access the value within a dictionary, the syntax is dictionary name, key, value. That's the syntax. So, for example, I actually don't want this to, but anyway, it's all right. So, for example, we have students. Let's call this again. We have student. I want to see what the educational background is. Very simple. The same method. Come here. That's the key. And just run it. You see BSc as a result. That's why we use that method to change it. Because if you just run the dictionary name and the key in that square bracket, it gives you the value. To change it, dictionary name, key, equal to the value that you want to change into. So let's refine this to access and let's just say, or change the value within a dictionary. Syntax is that. Any questions here? That seems simple enough. You could delete a key value pair. So let's say, for example, the senior director of the school reached out to Mr. Yinde and said, we don't want state key value. We don't want state in the student record because it seems that there's some kind of discrimination going on. Take it out altogether. How would you take it out? Del, DEL, standing for delete, student And what is the key state? It's deleted. Gone. Right? Let's all try to do that. Go delete the state. And they said, okay, since you deleted state, we want you to create another category. Let's call it hobbies. Kind of like what Professor had us speak about at the beginning. How do we create hobbies? Just come here. First of all, if you try to do like a get method, you are not going to find one. But how to do it is you come here, and first there are two ways to do it actually. Simple way to do it is let's create a category called hobbies here. Mr. Amano, what's your favorite hobby, please? Mr. Amano, are you with us? What's your favorite hobby?
I am a fan of reading novels,
Sorry?
Reading reading novels. Reading novels.
Oh, reading up. Oh, fantastic. That's good. So let's just say, let's just call this reading. So come here and say student hobbies. It will populate. There are some complex ways to actually create new dictionary categories or dictionary key value pairs. I wouldn't drag us into that right now. Do this. Create a create an additional category that we don't have here. Someone should do that and share their screen. Let's end with this one. Let's end here so we can quickly do some imports and some fun Python use cases around quantum physics, to be specific. If Professor has, if I get the opportunity to be invited again by Professor to actually grind out like the finer details of, Python foundational knowledge and syntax, I would absolutely be available to do that. But since we're trying to look at use cases around quantum physics, we'll have to jump into that right away. So
Okay.
I tried to, yeah.
I don't think we have any problem if you can accommodate us one more time.
Absolutely.
So, okay, that would be great. So that maybe
Absolutely.
we can then leverage on what we have learned these 2 months and see how we can then go for specific applications and use real library that are available for computational research, please.
Absolutely.
So we can schedule that for March. That would be great. Thank you for obliging us the privilege, because I was already thinking of that. And I'm also getting absorbed in what we're doing here. I believe all these basics are quite very important, very, very important. Maybe what I will also plead for is that you will share this Python notebook you share with us. So maybe you try to round up so that I will be able to pass across some announcement that can help us to be able to prepare for the final presentation. Thank you very much.
Absolutely. Let me quickly answer Ms. Ezekiel's question, and I want to let everyone know that I already created something for us. But Ms. Ezekiel, so there's a simple way to do it. So go to your student dictionary, which is this one, if you can see my screen, and create a key value pair, right? So let's say I'm trying to create a new category. I will come here and say, let's say, what could we use? Let's say car, just to throw it out there. Let's call this car, let's say Toyota. That's how you create it. You manually do this and run it. There's an automated method that is a bit outside of the scope of this lecture, but that's how you do it manually. I don't know if I've answered your question. So if I run this and go down here, if I call student again, you'll see that car would have been added to it. So car and Toyota. So you have to create key and value at the same time. Mr. Ezekiel, please did I answer your question? Yeah, there are more sophisticated ways of doing it, but just for the scope of this class, just making it manual so people don't get confused. I created about, I want to say, 1, 2, 3, 4. There are about 4 different notebooks that I created to essentially, it's treating lists, sets, tuples, and dictionaries, right? That we can leverage. I would share it with professors so that we can leverage them and use it. It's a lot more comprehensive than what we've done. But what I'll do is I'll add some of this into that as well to make it a lot more verbose for us. So you could reference it in your own personal time. So the next lecture, we probably wouldn't go in depth into this. We'll go straight into maybe loops and functions and importing packages, those 3 things. So it will be very helpful to go over this and do some personal work as well to facilitate easier assimilation of the new concepts coming up. So thank you so much for having me. I am super grateful to you, Professor, for the opportunity. And thank you to everyone that participated. You made it a lot easier to share these concepts. Thank you.
Thank you
Wow,
very
can we
much. We
please
appreciate it.
celebrate? Yes, can we please celebrate electronically, physically our presenter? I think he deserves an applause. Deserves an
Yes,
applause. Sorry to be
yes,
speaking continuously for the past. Yes, please. You can make your comment, please.
yeah, please. Well,
Question, comments,
I'm
please.
Professor Osman from Olabisi Onabanjo University, Agbewe.
Oh, it's
In
nice to
fact,
have you on, Prof.
yes, I'm joining this this presentation for the first time, and I was happy. But when I first of all joined, I look at him as I've joined it earlier before now. So I want to say that, and I want to thank the organizers too for bringing somebody like this, like this person into something like this. I want to thank you, sir, and you have done well. Please, more of this. God Almighty will be protecting all of us. We need more of this, especially in this, so that even one is even refreshing his brain. I was happy just listening to the way the man is taking the thing. Said I read mathematics, and when he started saying something, said theory, said I was happy as if say when I was in 100 level of learning. So please, yeah, God Almighty be giving you more effort to organize it. Thank you, sir.
Amen. Thank you so much, Prof. We are privileged to have you around, and we are glad to welcome you on board. I will share the link to our WhatsApp group. We have been on this for the past few months. We have the videos of our previous webinars. They are available online. So we will share that on the platform once you are able to join. We are glad to have you around, Prof. God bless you.
Please, I need your contact too, sir. I need your contact. So maybe I'll probably start you, sir.
Definitely. I'm sharing that right away, sir. So I will share my phone number, and I will also share the WhatsApp link for those who are here for the first time to join. And then thereafter, I will also put my phone number there. Thank you very much, Prof. We are glad to have you around. God bless you, Prof.
Thank you.
Welcome,
Thank
sir.
you, sir.
Please, more comment, please, especially those who are also joining for the first time. Please, let's have your comment, let's have your feedback. This feedback is what can make us to continue to do things like this. We are encouraged when we have this type of feedback. We are encouraged. We are doing this just to support ourselves in the academia in Nigeria, and then it's sacrifice all the way from us. Jeffrey is based in United States of America, and is making this sacrifice at no incentives. So, and the only joy we have is if our effort is actually impacting people. That's more than money for us. So we are really motivated by that. Thank you, Prof. If you have more comments,
hello,
please,
Professor.
Yeah, please go ahead.
Hello, Professor.
Yeah, you're welcome, sir.
Prof, sir.
Hello.
So we can hear you.
Yeah, I am calling. I am listening in, and I'm attending from Uganda.
Oh, we are
And
glad
I'm
to
very
have you
happy
around.
that I've gained so much from the presentation from Jeffrey. I wish he can go on and try to take us on some more important libraries like SciPy and then others which are using the mathematical and physical analysis.
Okay.
I'm a student actually doing my MSc at Makerere University.
Okay.
Sorry.
Thank you very much, sir. Thank you very much, sir. So definitely we have, we were to stop this Python series this month initially, but haven't looked at the fact that we've not been able to cover all the aspects we intended to cover. So we are extending it in March. This webinar comes up once in a month, the last Saturday of every month. And we have been on it. This should be our 6th or 7th month that we have been having different series, hosting different presenters. So by next month, by God's grace, we will also be hosting Mr. Jeffrey. He will continue, and in that particular one, we will definitely go in to look at more libraries that are relevant to the research we are doing.
Thank you, sir.
Subsequently, we are also going to machine learning, which I believe each and every one of us believe that is an aspect that is relevant to any area of research we might be working on. So we have a lot. We have a lot in stock to offer in the months to come. So please let's help us to just share this message across. It's purely free. It's purely free. And then the only motivation, like I said, we have now is that if we make a call and we have people who are listening to what we are saying and they are giving us feedback that, oh, what you are doing is impacting us positively, we are gaining from the concept. So that's just basically the things that we're looking for now. We believe in the future, we might be able to attract funding, but for now, we don't have it yet. So thank you very much. So I'm pasting the link to join the WhatsApp group, because that's our primary means of sharing information. So those who are not on the WhatsApp group can actually click the link to join the WhatsApp group immediately. And I will also be putting my phone number on the WhatsApp group and my name in full. I'm Professor Akelola Yinka. I'm currently serving as the Dean of Science at Edo State University, Uzaure, in Nigeria here. By the grace of God, I am the founder of this initiative. And the whole idea is that some of us went through rough road to acquire some of the basic skills that we have in computational science now. And I felt if we can make the sacrifice of releasing some of the things we are able to know to others, we can make Africa a better place, and in particular Nigeria a better place. So that's just basically the whole idea there. So I'm sharing my phone number 0062447411. So I've just pasted that also for those who might need it. I think we can welcome one of the comments. Yes.
Prof, sir, please again, sir. Is 080?
0062447411. Yes.
11. Okay, sir. Okay, Prof, sir. Thank you, sir. Thank you,
I will
sir.
appreciate a message from you so I can save your number to my Prof.
Yes, I will send the message to you now, sir. Thank you, sir.
Then the link to the
Thank you.
WhatsApp is also shared on
I've
the.
joined the WhatsApp, straight. I've joined the WhatsApp, sir. I'll
Great.
discuss something with you when we
Okay, no
maybe
problem.
at our something private
No
thing.
problem, my prof. No problem, my prof. Thank you so much, prof. Thank you so
Okay,
much.
sir. Thank you. Okay, sir.
Yeah. Any other comments, questions as for what we have done? What is the international code of Nigeria? +234. Okay.
Plus 234, yes.
Yes, +234. +234. Okay, thanks, Mr. Emmanuel. Any other question or comment?
problem.
Okay. Let me just quickly make
Yes.
this announcement. We usually do this every month. I will just make it as brief as possible. Now, we're making use of a Zoom platform that is premium in nature. Of course, as a Nigerian professor, I can't afford to buy that or to secure that. But that was made possible by the University of Colorado in USA. And it's courtesy of the fellowship I have with PhET Interactive Simulation at that university. I happen to be a fellow of that project. And so I will quickly take us through by sharing my screen to show you briefly what that is all about. It's also something that can enhance our capacity as researcher, as professor. So I'll quickly just give a brief overview of what that is all about. It's a way of recognizing people who have been able to make this possible for us. And it's also something that is educational, academic in nature, that can also help us to be a better person. Okay. So I want to share my screen. I'll just share any of my browser quickly. Any of my browser. Where's anyone here? Okay. Can I share? Yes, I'm sharing the screen again. Taking close it. So the website is phet.colorado.edu. Now, PhET stands for Physics Education Technology. It was actually an initiative of a Nobel laureate in physics in the year 2000, in the year 2001. And his name is Carl Willman. He won the Nobel laureate, and after winning that laureate, he thought of giving back to the society, and he started what is known as PhET today. Now, PhET, originally, his idea was to promote the use of teaching physics by making use of PhET simulations. But over the years, it has spanned across all other fields, not just limiting it to physics only. And so today, we have simulations, as you can see on this screen. We have simulations across physics, mathematics, and statistics. Prof, you can see that you have relevant areas here. We have simulations that are available in chemistry, earth and space science, biology. And another beautiful thing about this is that we also have sims that have been translated into several languages across the whole world, including major languages in Nigeria. So we have sims that have been translated into Nigerian languages like Yoruba, Igbo, and Hausa. So we can leverage on this to actually improve our delivery of educational content. So I'm a physicist, but I think I would just like to go through maybe any of these translated sim. Okay. If I click translated sim, I can go to the language of my choice. I will pick just a Nigerian language. And I think I will just pick a language I don't understand. Do we have somebody who speaks Hausa or Igbo here? I speak Yoruba, so I would like to pick any of that. Hausa. Do we have anybody who speaks Hausa and you are ready to guide me as I go through?
Yes.
Okay, great. So I will look for Hausa, please. If you see it before me, let me know. Hausa.
You are fast, sir. You are fast, sir. Just
Okay.
go to H. Yes.
Is it H or
It's H.
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 No. Just go to alphabetical order. Go to H.
It's
H.
not. Let me see the order with which is
I've
the rate.
seen it already.
Don't worry.
I
Let
saw
me sort it like this. I think I will be fine. So I've sorted based on the language. Okay. So I think that will give me what I want. So I've seen Igbo here. Okay.
Okay, we can speak Igbo.
Okay, you can speak, but I think let me go with Hausa that I chose earlier.
Hausa again.
That's all right.
Hausa again.
I'll pass it again, right?
Yes,
Okay,
sir.
I've seen it. Great. So I can click this Hausa now. So we have 104 simulations in that category that have been translated to Hausa language. And so we can pick any of these. We can also go under various category. Let me make it a bit smaller. So someone will have to tell me what all these are. We can choose by subjects, physics, different topic under physics. We can also come under mathematics. We can come under each of these categories to choose and search for a simulation. We can also go by category. We can go for the one that are relevant to university to apply our filter, okay? We can look at the one that we have the old version that have been released. So let me just pick the one that are relevant to university. And then please, do I just go to electricity, make it a bit faster? So I have this that has come up here, okay?
Yes.
So somebody should tell us what it's talking about. Who is our guy?
Kayan aikin hada hanyoyin da lantarki.
Okay, tell us what's he saying?
Items that I use to bring to connect electricity.
Okay, great. So if you bring this to class, to children to teach them in their own language, I believe it has some level of comprehension compared to just disseminating this knowledge just in English. That is one of the beautiful things that have been achieved by this first interactive simulation. Okay, now we can download this and use it offline. So you don't need internet all the time to actually make use of this. Okay, once you click this, downloaded an HTML5 version file that can be run anytime, any day. Once I click that, I download it. In fact, I will share this with us, the platform. So once you click this as it is now, I can share this even right away on our WhatsApp group. Let me share this on our WhatsApp group. So if you double click it, you can actually do exactly what I'm doing here, right on your phone, right on your phone. So it's as simple as that. You can begin to use it, just as simple as that. So if you download what I've just sent to the WhatsApp group, you can actually run this Hausa version of this sim I'm actually using. Then I can also embed it even to my website or to any other platform like my Google Classroom or LMS that I might be using. Then I can run it online. So I want to quickly go ahead and run it online here. Now I haven't opened this. Okay, what's this saying, sir? Hello, are you there? Okay, so what's this saying? Tell us what we have on the screen.
Okay, karfin torowa lantarki. It's like a meter, an evaluation meter.
Okay, great. So I can open this very quickly and I can begin to pick component. This is an AC source, okay? I can pick a resistor that I want to connect to this. I can pick wire or cable, connect this circuit. I can place a bulb here. I can also connect a cable to connect these together. Then I can bring another cable to come here. Do a simple circuit, a simple serial circuit, then get another cable to loop this, okay? If I close this key, I have a circuit. But what is happening here? Because I have an alternating current, the bulb is coming up and is going off. I can bring in, this is just like a oscilloscope. I can begin to measure, oh, what is low key? Somebody should help me with that.
Lokaci.
Okay, lokaci, what's lokaci?
Lokaci is time.
It's time, okay? So I'm having, what do I have here on this axis?
I can't see it very well from my
Very
side.
well, okay. But I think it's talking about voltage, okay? So, yeah. Then I can also begin to display what the current looks like. We can say a sinusoidal signal, okay? I can also bring a multimeter, voltmeter to measure the voltage as well across any component within the circuits, okay? Across this resistor, I can see the voltage. Then I can also go ahead and measure the current at any point in this circuit, okay? That's what we have. At any point in the circuit, I can measure the current. Now, that's not all. I can also display the values, okay? Then I can show conventional currents instead of seeing the electron flowing through, okay? Then I can also have other components that I can use to test which material actually conducts electricity and not, okay? Then if I replace this, let's see what is happening now. You can see I'm having sinusoidal display all along. So if I replace this AC source, I can delete it. I can also change the value, please. So I can set up a simple experiment and change the value of my voltage, my frequency, and come up with a table that student can actually do an experiment in the real life experiment that with an immersive experience. That's one of the beauty of this first simulation, okay? Now, if I remove this and I replace it with just, oh, I was to use this here earlier. My intention was not to use a battery, but to use resistor, okay? So I'm now placing irrespective of the polarity, okay? So you can see that this time around, we have the lights consistently on. It's not blinking. And the DC is showing straight signal. We don't have a situation whereby we're having alternating signal. So we can use this concept to differentiate or illustrate to students the concept of AC, how is it different from DC and things like that. And all the basic electricity can actually be handled within this area. We also have a portion here that talks about the RLC circuits that can also be handled. And then we also have the third part that talks about a more advanced lab. Okay, so I think that's what time will permit us to do. And I believe we've been able to gain one or two things. So I will encourage us that we should go ahead to the website. Let's register an account, okay? And then once we're able to register, let's explore some of these things and see how they can add value to our profession as educators. Thank you very much for your time. Any comment on that? Any comment on that? Okay, let me also mention that we also have the opportunity. We have the opportunity of even having the whole of this package as an offline package, whereby you have so many of them. On my own system, I do have it, where I can launch it offline, not just having a single SIM, but all the SIMs as a full package executable that is also available. Maybe I will try to also share that link for those that may want to install it locally. And having said that, I want to say a big thank you to every one of us that have been able to make it here today. I want to especially appreciate our presenter, Jeffrey, for creating time. He has been able to deny himself a sleep in order to be able to attend to us. We're not taking it for granted. We are most grateful for your time, and we appreciate the effort with which you have put together to impart us today. And we pray that God Almighty will bless you. To my distinguished professors in the house, to my respected colleagues and academics who have also made time to be here. I want to say your presence is much appreciated. And to those who are joining us from diaspora, like Mr. Emmanuel, your presence is appreciated because one thing I keep on telling people, even if you have good intention and a project you want to deliver, and you don't have anybody listening to you, then it's of no use, it's of no value. So even if you have the opportunity of imparting life, that you make it here, your presence here, we are not taking it for granted. We appreciate your presence. You understand it? And even though we are the one giving out the information, we still appreciate that you make yourself available to be part of this whole process. And I believe together, learning together, growing together, we can actually be better than who we are at the moment. God bless you. God bless you. God bless you.
Amen.
Enjoy the rest of
Amen.
your weekend while we continue our conversation on our WhatsApp group. God
Thank you,
bless
sir.
you.
Thank you, sir.
You're most welcome.
Thank you so much, Prof. Really
Thank
appreciate you.
you.
I appreciate
Thank
your
you.
gesture.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir. Thank you, sir. Thank you, sir. Bye, sir. Thank you. Nice to see you. God bless you.